loud. All right. Final checks. All right. Hello, everyone, and welcome to today's session on validation tips from professional node operators. As you all know, the performance of Ethereum validators are open for all to see and measure on-chain, and these metrics can be used by protocols to determine certain benefits, such as qualifying for additional rewards in the case of the Lido community staking module, or earning certain on-chain credentials in the case of OBO Technic credentials and SSV verified operator status. However, as solo and community stakers, we are usually new to the craft of performance tuning, and venturing beyond the scope of a basic setup can often feel quite scary. But fortunately for us today, we have the privilege of tapping into the brains of two professional node operators, Sergey Yakovlev, I hope I'm getting it right, I'm not butchering your name, and Nikita Tumanov from p2p.org. Respectively, they are the Ethereum tech lead and the blockchain analyst lead. If you don't know what that means, it means they run Ethereum validators for a living, and they definitely know what they're doing. For those of you who do not know what P2P does, they are basically the leading non-custodial staking platform, supporting 40 proof of stake and restaking networks. They serve more than 130 institutional clients and over 90,000 staking delegators globally. Their TVL today stands at more than $4 billion US. And before I forget, they are also one of the professional node operators serving in the Lido curated module. So again, long story short, they know what they're doing. They do this for a living. And today we have the opportunity to learn from the best. And that's enough yapping from me. Let's hear from the experts themselves. Nikita, Sergey, anytime you're ready, the floor is yours.
Yep. Hello, everyone. So we'll split our presentation in two parts. The first part, it will be like on me, and our part, it will be on Nikita. Let me share my screen. Yeah. So right now you should see that. Do you see? Everything's fine?
Yep, we see your screen. And guys, if you guys are feeling shy afterwards during the Q&A segment, feel free to drop your questions in the chat and I'll ask them on your behalf. Otherwise, you can raise your hands, and then we'll get you to unmute yourselves to ask the questions during the Q&A segment right after this presentation by Sergey and Nikita.
Yeah, feel free to ask questions. We'll try to answer all of them. So let me start the presentation. So we will speak a little bit about performance in our presentation. So introduction was made. So we are from P2P company. We are two. It's me. I'm Sergey. I'm Ethereum tech lead, and Nikita is blockchain analyst lead. So a little bit about P2P. So we almost always like in top 1, top 2, top 3 in Lido curated model, for example, on RAVER in rated network. So I hope we know something that can help you to get like your steps in like a next level. And we will start from like the main question: what is performance for node operator at all? Because like performance, it's very tricky word, and different people they mean different stuff. And as we can see, like we have several ways to define what performance is. Like in general, there are some simple ways how we can define our performance. It's like participant rate, proposal rate. It's usually for new networks who doesn't make any complex metric how to deal with that. And we have some universal metrics like APR, because it's like economic effectiveness and how you work, how you're earning your money and so on. It's very important in all networks. And exactly on Ethereum, we also have a special complex metric. It's called RAVER from Rated. And we will speak a little bit about these two last metrics. So let's start from APR. APR is very simple in general. It's just money which you will get like from operating your nodes, operating your keys, working the network, and so on. In Ethereum, we can split our APR in two parts. It's like yearly rewards and CL rewards because we have two layers, let's say two small blockchains like in Ethereum. Yeah, it's execution layer and consensus layer, and they have different types of rewards, different source of income. APR for consensus layer is bigger than for execution layer, and for consensus layer we are getting rewards for some duties. It's like three main area of these duties where we can get like rewards for that, and it's very stable, and we can easily to predict how much we will get that because all formulas are well known. Usually we are making all of this stuff like constantly without any like intentions and so on. It's really stable metric how to calculate that. But on execution layer, it's a little bit different story. Execution layer, in fact, we are getting rewards from our included transaction in some form of that. Like for example, for vanilla blocks, it's just priority fee. For MEV blocks, we have some bits and MEV rewards from remote builders, and it's really hard to influence on that. Because in consensus layer, it heavily depends on us and like in the state of the network, not like everything related on us, but anyway. But in execution layer, it's a little bit random stuff, and it has random nature. You can predict that and somehow influence on that. But thanks God, we have CSM, and CSM also make it smooth, so you don't need to think why someone got, I don't know, really big rewards and you got lower. CSM makes it smooth and helps like all operators to get it stable. If you are talking about rewards, let's dig a little bit on each of them. So if you're talking about consensus layer rewards, we have three rewarded duties. It's not all of them, but it's some all our actions happen around all of these duties. So the first one, it's like attestation. Actually, we have like from network perspective, we have one attestation, but it contains three votes. It's source, target, and head. It's related to Gasper. It's like consensus protocol. And in general, we should make it like correct and in timely manner. For attestation, we have rewards and penalties. So it's better to make all attestation and votes in time and correct because you're receiving rewards for that. If you skip them or make it wrong, you can get penalties for that. Attestation, it's very stable stuff because you're making attestation constantly, once per epoch per key. So like it's super stable and super easy to track metric. Besides that, we also have duties. It's called block proposal, block production. There are no penalties at all. You just get like zero money from that. But if you making block, all your rewards depends on value of included attestations because like all attestation they have some values, yeah, and you just you can imagine that like you are getting some part of all of this included attestation. So it's better to include more attestation and more like correct timely attestation in your block than like skip someone and so on. In general, block proposal duties, it's very rare stuff. Right now, we just calculated before this presentation, we got like one validator can approximately produce one block in 129 days only. So it's not very easy to track that because it's rare, and you just maybe got one block per year, maybe got 2 blocks, 3 blocks, something like that. So it's really rare, not constant, hard to track. And the last one, duties, it's called sync committee. Sync committee, it's like a special attestation. Like technically, it works like attestation, but it has a little bit special committee, and it has only one committee, and it works much longer. It also, like in attestation, has rewards and penalties, so it's better to make right and timely attestation and don't skip them. And it's still rare. We also calculate that per one validator, like your chances to be in one community, you will be there approximately in only 138 days. So it's super rare stuff. If you look at like initial consensus specification, we will see like different fractions in our like all possible rewards, and actually we can see that rewards related to attestation is the biggest one because it's like timely head, timely target, and timely source. So for APR, it's really good. For CL rewards, it's really good to focus exactly on attestation. Besides of that, we also have EL rewards. EL rewards, it's also related to block production, but from execution layer point of view. And execution layer, when we are producing our blocks, we are also including transactions, yeah, because it's like value for our users and for our network. And we have, let's say, two types of block, vanilla block and blocks from MEV, yeah, from relays, from remote builders, yeah. And for vanilla blocks, we just gathering priorities fees from all our transactions. There are also no penalties. You can include 0 transaction and you will get just 0 money. So it's better to include actually as much as possible transaction in your block, and all of them should be really valuable. Really hard to influence on that. The only one thing which can like influence in public mempool is just to have working mempool with peers, and that's it. You can't do like anything special related to that in general. From MEV point of view and from remote builders, we have a little bit different process. It's like called usually PBS, yeah, proposal period separation. And on this architecture, we are getting bids from different remote builders, and we just choose only one, and this remote builder pay us for making blocks. In general, we also can influence that like in very some hard way. The only possible solution and best strategies here is just to connect all possible relays builders and cover like all surface on MEV area, and that's it. Yep. And the next one is RAVER, and RAVER will introduce Nikita.
Yeah, hello everyone. Now, basically, our main focus is already Sergey mentioned, is rely on two key metrics, is RAVER and APR. A short link overview why we are focused on RAVER. Basically, we're working with several institutional clients, and most of our clients are looking into this metrics. And when I was in conference, several operators also discussed this metrics. And basically, that's why one of our KPIs for several quarters was to be in top of this leaderboards, right? So basically, what is this RAVER? RAVER is a performance score that combines metrics from both the execution and consensus layer. However, as you can see, the attestation performance carries more weight than proposal one. Basically, we will specifically deep dive into two critical components of RAVER that includes in attester effectiveness. It's correctness and inclusion delay, because based off our researches, this is the most impactful metrics when it comes to RAVER score. Can you please, Sergey, next slide, please? Thank you. So on this table, you can see data from 5 different operators. I just like put the top 1, 5, 10, 15, and 20 for last 30 days, starting from today. And according to this table, as you can see, not significant difference between head rate and inclusion delay. But as we can see, the RAVER score is a significant difference between each of them. So in short, I can describe that we have several situations when, because of one problematic attestation where we have inclusion delay from approximately 40, we have dropped in rated by 20 place. I mean, so we was, for example, for Wednesday in top 2 or top 3 placement, but at the next day when we have such problematic attestation, we was in top 20 or 25 placement, only because of this difference between inclusion delay average value for these 2 days. But as we know, inclusion delay is just like only the difference between the commit slot and the inclusion slot. And the main reason is the untimely head vote that we have in this attestation. So basically, yeah, let's jump into analyzing head votes. We just basically define them into 5 categories. 2 of them is just like the correct and untimely, when everything works perfectly and the validator receives full rewards. And when we completely missed the attestation, so it wasn't included at all, and so we resulted in 0 rewards. The 3 main problematic cases that we defined is the correct and untimely, and this is when the head vote was accurate but arrived too late, and this caused the reducing rewards. Incorrect head vote and untimely, this just like incorrect means that the parent block root is incorrect and the vote is included, but the head block is wrong. And incorrect and untimely, it's just like a worst case combination where it's when it's late and incorrect. So we're basically leading to minimal rewards. Yeah, as you can see on the chart, basically this chart is based on our validators, and most cases when the head vote is untimely. Incorrect head votes is mostly relied on. Basically, here you can jump into the next slide where we represent several reasons why it happens. Yeah, so one of the reasons that is relied on incorrect head votes is just like when they have incorrect network time protocol. So it leads just like to voting on the wrong block. Also, the reason is that the block we received too late, after 4 seconds. So it means that the parent hash root was from the previous block, and reworks and forks. But as you can see on the previous pie chart, the incorrect head votes is not the significant part of it. The most powerful part of our wrong head votes is the untimely one. And can you please, Sergey, jump to the next slide? Yeah. So untimely head votes. Regarding untimely head votes, the most case that we have during the research is when the next block that should include our attestation was missed or forked, and because of it, our attestation due to LMD Ghost greedy algorithm wasn't include several blocks in a row, and it affects to have you approximately 40 or 50 inclusion distance. And because of this such cases, when somebody missed block where your attestation should be included, it affects our performance significantly. So basically this case is pretty rare, but we, from our side, we can't do anything here. So it's a random one. And when you are a large operator, this affects your score significantly only because the rated team use the only average value to calculate your inclusion distance. So basically our reasons also is that there is no space in the block. So just like let's estimate that all blocks are proposed, and there is no space in the block just like to include your attestation there. And then also the reason is that your attestation is not so valuable due to greedy algorithm that I already mentioned when we have a case that the next block was missed or forked. The next slide, please. Just like regarding RAVER insights. Yeah, here's just like short info that when we defined during our researches. The problematic cases with RAVER is that there is no formulas regarding sync commitment duties. So there is no anything regarding sync commit duties. We basically don't include it there. But for example, we have a case when one of our clients signed them, but their validator was included into sync commit issue, and because of that, due to some old bug in Ethereum, they have penalty for 500 epochs, something like that, 512 epochs, and their validator exits with lower validator effective balance than it was before deposited one. So basically, but if we look into RAVER score, when we'll just like look into their performance rate, it wasn't affected because no sync committee duties included there. Also, missed blocks doesn't make a big impact. This means that basically, for example, we are as P2P, we proposed several thousand blocks, but if we missed 10 or 20 of them, it's not significantly affect on RAVER score at all. Because the proposal effectiveness has lower weight than a tester one, than for consensus one. And then you just like divide two figures. I mean, it's just like several thousands minus several thousands. And you just like include 20 or 30 missed blocks. It's not affect significantly. And the two cases that we defined and want to improve, the first one is just like to remove simple arithmetic average value for inclusion delay. The reason is just like I represent some sort of plot, how it can improve. Basically, the Weinberg mean can significantly reduce the metric sensitivity, and we can just like reduce this effect when we have a random situation that the validator that is not yours missed the block where was your attestation. And because of LMD Ghost, your attestation hasn't included 40 slots in a row, and that's why you have higher inclusion rate. And with Weinberg mean, you can just like decrease the effect of such situations. And the point regarding that missed attestations affect less than inclusion distance, because as you can see on the chart below, for example, for one validator, let's just like imagine that we have just like a node with 500 validators, and one validator had 40 inclusion distance, and for 1 hour window, and several validators had missed attestation. The RAVER score will be significantly lower for the attestation that has 40 inclusion distance, rather when you miss several attestations in a row. So yeah, I think that's all from my side. I will pass the mic to Sergey.
Nikita, if you don't mind, just so we understand how to interpret this chart, right? Wouldn't this mean that the missed attestations has a greater impact on RAVER than inclusion delay?
Basically, no. It's hard to read. Sorry for that, but what I want to represent here. But basically, from our perspective, if you missed 1 or 2 attestation for not set up with 500 validator, it should significantly affect on your performance rating, rather than you have 1 attestations with super high inclusion delay. And here I just like represent that if you missed, for example, let's estimate 20 of 5 attestations with setup of 500 validator, your RAVER score will be something about 0.97. But if you have only 1 attestation with inclusion delay 40, your RAVER score will be lower, and it's approximately 0.95. I think we can just like estimate it in percentage rate, so it will be 95%. So basically, It means that according to RAVER score, you will have higher performance rate if you missed 25 attestations rather than you missed only 1 not like Mist, you have only one with inclusion delay 40 or higher. And it's just like, it shouldn't be like that. So yeah, this is my point about it.
Got it. And the inclusion distance is measured in terms of a time, like milliseconds, or how is it measured?
No, it's just like a number of slots. It's a difference between your commit slot and inclusion slot. So, for example, you was commit to be in slot N. Basically, the difference between the normal difference is 1. So your difference between commit slot and inclusion slot should be equal to 1. But if you
Right.
have more than 1, it means that your attestation was included with a delay, with a
I see.
N plus 1 slot. So it means
I
that
see.
a network doesn't include it in correct form.
I see. Okay, thank you.
Yeah. So the next one, if like we spoke a little bit about APR, about RAVER, and we got some insights related to most problematic stuff. It's like inclusion distance, of course, and it's highly coupled with actually head participant rate and head correctness. And in general, we should focus on that. But before that, let's focus a little bit about how it works. So in general, like all slots in Ethereum, we can divide on 3 equal parts. Yeah, we have like special names, and we can see that here. We have like 3 intervals. It's like before 4 seconds, from 4 seconds to 8 seconds, and from 8 seconds to 12 seconds. On the first interval, we should make block and prepare attestation. On second slot, we should send this attestation at least, and we are starting to make aggregated attestation. In the first one, we just sending this aggregated attestation in the network, and the next proposer just preparing their own block for the next slot. And like what we can get from that. Actually, we see that in general in network, we haven't any problem with any attester or aggregated attestation timings. And of course, there are no, at least right now, timing games. So we don't have any problems related to exactly making creating attestation or signatures or something like that. The only problem part there, it's like the first interval, it's like from 0 to 4 seconds, and else we have in network this stuff related timing called timing games, and these timing games, of course, influence on that really significantly because they just moving like this event of block creation from the start to the end, and it has tendency to receive late blocks because like late blocks, what does it mean? We have like 2 or let's say 3 main parts where it's just time when you create blocks, and after that you have 2 main timings. The first one is propagation, and now one import. So you need to propagate across the network, and after that you also need to make all checks, import that block, and set this head in your beacon state. And late blocks, it means like all this timing, they just moved to the right corner to 4 seconds, or maybe a little bit later, or maybe a little bit before that timing. So we can say that the main area, the main focus for node operator, at least right now, because like everything is changing and so on, but at least right now, the main area, this is exactly all stuff related to blocks. It's creating, propagation, and import of the block. So actually, focus should be exactly on nodes. There are no like super big point, at least when everything is work, you don't have like any really low level hardware, unstable internet, and so on. If everything is fine, you should focus exactly on how your nodes works, because validators, timings related to creating signatures, and so on and so on, it doesn't matter in general, because like nodes make significantly more influence on what happened with your rewards and with your RAVER metrics. So we can say several tips related to that. And like I previously said, all of the stuff, and the main thing you should focus on, this is exactly head, your like head correctness, head participant rate, and it also influence on inclusion distance, because it's like inclusion distance is the most valuable influencer in RAVER, for example. And for doing that and focusing on nodes, we have several tips. The first one, like everyone should produce blocks yearly, of course, like by specification, it should be done at 0 second, but in real life, it's a little bit moved from the left corner because like we have delays and so on. But anyway, it's better to produce block yearly. It helps like attesters to attest your block yearly without getting blocks in the corner for second. In general, like for all validation, because we have Gasper, we have LMD Ghost, we have Casper FFG, yeah. For all of them, it's very important to make all votes like majority do that. And in terms of this majority nodes, you should be closer to this majority nodes. Because if majority nodes, for example, receive this block after 4 seconds, it's better for you also get this block after 4 seconds, for example. So you should be like majority. And of course, you should be, in general, be closer to majority nodes. What does it mean? It also means that you should have a really good internet connections. Yes, like P2P connection and P2P protocol gossip, which we have, it has like some randomness. We are not choosing nodes. Yeah, you know, we just collect randomly to some nodes on internet, and we don't know how close they are to us. They can be like in different continents and so on. But anyway, it's very good to have a good stable internet connection. So in general, you should be closer to internet exchanges or layer 1 ACPs, internet providers, because it just reduces latency for you. And reduce latency, you will receive block yearly, so it's more chances that you will make a right attestation. Better to have good CPU. Why? Because this is exactly the point which reduce your blocking part time. And as we can see, like blocking part time, it's also very important because in general, you can influence on that directly. Not like, for example, your geographic location, or sometimes it's really hard to get like a connection in internet exchanges and some hubs and so on. But CPU, this is like our own stuff, so we can influence on that and reduce some blocking part time. Also, it's a good way for reduce import block time. This is have consensus layer node closer to execution layer node. Ideally, you should run these two processes in the same node because you will have connection via local host. So it just reduces latency. You don't need to go through some hubs, switches, and so on to a different computer because it make block import longer. In our one, it's also nice to have multi-node validator clients. Why? Because in that case, like today, one sale node beta like has lower block import time, for example. Tomorrow it will be totally different for some reason. So you can't like choose focus only one node in general because like time time and your performance can be changed like during the time, and that's fine. So actually, it's better to have some validator client who can work with different nodes, or at least you should have different nodes, and maybe you have some ability or scripts to connect to different nodes at some period of time. Yeah, but especially for multi-node validator client, you can compare attestation data yeah, and choose like the best one from them. For example, for majority strategy, you can compare, like, for example, three nodes, three attestation data from three different nodes, and choose like the best one and the stable one. And it gives you more chances that you will make like a right attestation. And in our one, it's also like if you're focusing exactly about nodes and about blocks, it's really good to monitor your head events when we get your blocks and when you import this block. Like all clients usually have some metrics related to that, so you can get that from Prometheus or something like that. But also there are like all consensus layer way supporting some streaming of events, and head event it's one of them. So you can actually subscribe to this event. For some software you can write that your own stuff or use Xatov, for example, and you can monitor like head events from your nodes and decide which node is better right now. Beyond the RAVER. So in general, we consider it like two metrics. It's like APR and RAVER, but anyway, for network in general, it's they have more, let's say, duties or more tuning, which can help like network to work better. And RAVER, for example, or APR doesn't count that, and you also need to think about that. It's a good way to think about that. So just some list, yeah, it's like proper timing. So you should make like everyone in timely manner. Sync committees, of course, it's very important because they give you like additional rewards, and RAVER doesn't count that. All aggregation stuff, like for attestation for sync committee, we have an additional step. It's called aggregations, and we have aggregators in our network, but you won't receive any rewards for that. But still, it's very important to have in the network. It's like P2P peering, efficient message propagation, geographic diversity, client diversity, all other stuff. It's not everything like lay down on APR, on RAVER. You also need to think a little bit wider and make your nodes, make your validators like good for the whole network, not only for you. And small notes about our infrastructure for Lido, how it looks like. Yes, I understand we like a big operator and everything work on scale in our infrastructure, but just to see, just to show how it looks like in our company. So we have like Kubernetes-based infrastructure, all stuff only in Kubernetes based. It helps us to like manage all this stuff very fast. We have two types of clusters, bare metal cloud managed in different regions. Right now we have more than 20 Kubernetes clusters in a lot of regions. For example, we are running execution layer and consensus layer nodes always together because it just reduces latency. High frequency CPU, of course, in our case, we are a big one operator. And we also have reliable infrastructure. We created our architecture based on avoiding single point of failure. So we have multiple nodes, multiple validators, multiple places with shards for keys because we are using threshold signatures. It also helps us to reduce outages of our services because we can lost or upgrade or change or replace all components in our network, in our infrastructure, without making outage for our, for example, attestations. Yeah, and it's really nice to have that property. About data tracking, we also like. I think Nikita will speak about that better than me.
Yeah, I can share. Regarding data tracking, we use Balwal by Lido team. Basically, we use there's two mode when you can deploy your Balwal for finalized epochs and for streaming one. The finalized epochs we used for reverse calculation because we basically need to wait to finalize epochs before starting calculating rewards. So to have accurate rewards, we use Balval in this mode. The second mode is just like a live streaming mode to monitor your performance rate, but basically we only use it only in finalized version for rewards calculation because right now we don't have any other tools that we can use for it. Also, we use ChainD by a testing team. We use it to understand what is the type of head vote. They have pretty good table with information regarding is a F head correct or not with where beacon parent block root. And also we use together with it prop D, prop C to understand the latency for blocks in attestation. So just like the time when we proposed or we get the block and attestation. Ethereum ETL just like a classic one for yield indexation and Exatov by Ethereum Pandas team. Basically, we want to remove in the future our serial calculation to XAT one. Before 2 years or 1 year ago, there wasn't so much what we can extract from it. But right now, according to our latest research, we already have attestation time and block time. And basically, we are planning to migrate most of our performance calculation on Xato indexer. Yes, that's all from my side.
Yeah, and small note about Xato, because everyone actually can speak with Ethereum Pandas ops, yeah, and they can configure their nodes to send like Xato stuff to public Xato server, let's say like that. And after that, I hope you will be able to compare, for example, your head events with others in networks and maybe to make some changes based on that. Yeah, so anyway, it's like a good way to see when you are receiving your blocks and compare that with all others. Yep, that's it from our side. So if you have any questions, you can say something and we will try to answer that.
Thank you, Sergey. Thank you, Nikita. Very insightful indeed. We do have some questions from the chat. But before that, maybe let me just open with a very high-level question. You know, there are certain metrics and performance measures that deal directly with APR and the rewards, and there are some metrics and performance measures that you know, for example, RAVER, right? It doesn't measure the amount of rewards or APR directly. But do these non-rewards metrics translate into rewards eventually? You know, should we optimize for RAVER because we get more rewards from that?
Actually, yes, but you know, all metrics, this is some approximation of your work. And yes, it has some correlation, but I'm not saying like direct correlation. It has with some coefficient. Let's say about RAVER, yeah, because RAVER it's more like technical network-wide metrics, not based on APR. And on RAVER, like RAVER, it consists of two major points. Yep, it's proposer effectiveness and attester effectiveness. So if you make your like attestation better than the network and you also propose blocks better than the network, your RAVER will be bigger. And it, what does it mean? It means like that your CL rewards would be bigger. So you will have more CL rewards. So your APR also will be bigger. So in general, if you're, because like exactly RAVER, it's focused mostly on consensus layer. And if we have bigger numbers in RAVER, it means like we will have bigger CL rewards. So we see some correlation here, but it's just not direct. Like if you have, for example, 50% of RAVER, it means the CL rewards, for example, one if, and I don't know, 90% of RAVER, it means like two ifs, not like a linear correlation. But yes, correlation, of course, it exists.
Yeah, that makes sense. And the pie chart that we are seeing here, is the breakdown of the sources of node operator rewards, or some other kinds of weightage?
This is like breakdown of consensus layer rewards. It's from Ethereum consensus specification actually. So how we wanted to divide, like, let's say 100% of all rewards in consensus layer between different duties. Yeah, and we see, like, for example, in general, in average for the network in the long term, we see like sync committee, it's really small, like fraction there. Proposal, it's a little bit bigger, but the most rewards for node operator, it will be exactly attestations. Yeah, this is exactly for CL rewards, of course, because also we have YL rewards and a little bit different story there. But for CL rewards, the majority part of your rewards, this is exactly attestations in long term.
Makes sense. So it seems like being timely is a major contributor of your CL rewards, which brings us to one of the questions in the chat. If you can go to the tips slide, there's this tips 2 and 3, which deals with being closer to majority nodes and closer to L1 ISPs. How do we actually do that? Would something like, pointing or designating certain boot nodes or certain nodes that are reliable, would that help?
Yeah, it's a super tricky question, and we're also trying to find the solution how to do it, because actually you can't, and it's like honest answer to that. Except several things. What we can do, like in general, for example, like what is majority nodes at all, like in the network? Because, for example, we have like our nodes in 4 continents, and we are, for example, in Australia, we are creating the block and sending them to Europe, to Asia, to North and South America. Yeah, and of course it takes time. And a lot of time, and different time for different nodes there. It's totally random in point of view, like your peering. You can control that, but you still like can control, for example, number of your peers. So you can, for example, make more nodes and make more peers, but also it's also a little bit tricky, because making more peers, it influence on your performance, because you need to replicate all messages for these peers. So it's not like, for example, we have 10 peers, it's bad, and we have 100 peers, it's much better, and 1000 peers, it's super perfect. Actually, it will be like 10 peers bad, 100 peers good, 1000 peers is super bad, because your performance, like your software, will be struggle for making a lot of messages for your peers. So it's tricky. It's heavily depend on your software, on your hardware, especially. You just need to try to tune that. For example, the number of peers is the first thing. Another thing, it's geographic, your location. And of course, as far all of us know that like the most nodes placed in Europe and in North America, yeah, if you place a node there, it's like you will have more like probability that you will get nodes from them, and it will be closer to you. But it also against the healthy parameter of the network, because we need geographic diversity. And if we will spread all our nodes, like let's say in equal way between different continents, between different locations, it will be better for you, and it wouldn't be matter where you place your nodes. But right now it's all nodes highly concentrated in 2 major regions. It creates some problems. Yeah. So it's super tricky.
Indeed. We have one question from Dimitri. Dimitri, you want to go ahead?
Yeah. Thank you. Can I ask, first of all, thank you guys for an amazing presentation. And I really feel that you guys are grinding it to the very bottom in terms of investigation and maximizing performance. But let's assume that I'm a very beginner solo staker. I just got my DApp node. I plugged it in, select some random clients, and then I see that my validators are not performing super great. What would be the first three things that you will advise me to check or to tune to most likely get some improvement in terms of performance? So again, I'm a super noob. I haven't configured anything specifically. I'm just running validators, and I see that my performance, like my RAVER, is like 85% or like even 80%. What would be your top three advices that I should do immediately to try to improve my performance?
Yeah, super good question, actually, because it's heavily different from our perspective because we are like a big provider. But I would focus exactly on nodes in your case and on exactly that part. Usually it's not software, actually, because software almost like, let's say, stable and all of them works almost equally with some difference in some time, depends on bugs, upgrades and so on, but it's really hard to choose exactly only one and live with that like for a long time. I would like to focus on a little bit different and let's say hardware stuff. So it's stable internet connection and it's better to have a really good connection for internet. It's the first one. Another one, it's like good CPU. So you have like, for example, have latest version of your DApp node or another hardware which you have there, something like that. And the third one may be disk because if you have, for example, HDD or I don't know, very slow disk, it also can influence on your block import timing, and you can improve that just working with very fast disk. So like this one. So actually focus on hardware and on internet connection. Yeah.
Gotcha. Thank you so much.
Yeah.
Anyone else has questions?
Guys, do not hesitate to ask like not that simple questions like I did, but Sergey and Nikita, they are top tier professionals, so you can ask them super tricky questions, and I hope they will be able to answer.
Yeah, usually it's the simplest questions that is the most difficult to solve, so they are the best guys to address them. While we were waiting for the rest to, unmute themselves and raise their hands, right? Maybe going back to this optimization around number of peers. So for example, if I'm in a country, let's say some obscure island country, with probably 10 nodes in the region, how many peers do I set in order to optimize my performance?
Yeah, it's also super tricky question actually, and it's not only question for solo staker, for example, but it is also a super good question for any professional operator because it's heavily depends on situation, on the time, on the number of bugs in your software, and so on and so on. And for example, we in our infrastructure we trying to adjust that. So we just making some experiments time to time and just to see, do we see any difference there or not? Because, for example, we are collecting a lot of metrics and sometimes we see that particular region, it performs better. All nodes performs better exactly in this region. And sometimes like getting metrics from Xato, we see that we just getting blocks for majority of blocks yearly. And what's the reason of that? It's usually like we closer to internet exchanges or some big hub there, and this is the reason. So we're trying to adjust these numbers, and exactly it's the problem here that it also depends on hardware because it creating stress on your hardware, on your CPU, on the memory. So you can't just make let's say 1000 peers and works perfectly after that. But for example, for us, how we set that? for all almost for all consensus layer clients, we're using 150 peers. We like last year we made several tests, and we see that increasing more than 150 exactly for our infrastructure doesn't give us like any performance boost. But decreasing that numbers, for example, to 50 or 70, it actually reduce our like percentile of our incoming blocks. We have more peers, so it means like we will receive blocks earlier in general. So I would answer on that like no numbers, particular numbers. You need to test that. But let's say just for 3 days or for 1 week, you will choose, for example, default 50. After 3 weeks, you will choose 70. After that, you will choose 100, and you will see it's better or not like that. Or this is the only way. Yeah.
I see.
No simple answer, unfortunately.
Assuming you are in a region with, let's say, US or Europe with a lot of other nodes close to you, you can definitely push your peer count up to 150 and it will decrease your block import time. But if you are in a region with a small number of nodes around you and if you increase to 150 peers, it could increase the chance of you connecting to a further peer and hence increasing your block import time. Am I understanding this correctly?
Almost yes, but not like 100%. When, for example, you're in Australia and let's say all nodes in North America and you will create in 150 peers, it still helps you to receive blocks earlier. Why? Because it reduces network diameter. Yeah, because like which I saw, for example, the last time from if research forum, yeah, about diameters in the network. For 9,000 nodes, it's like I think approximate number nodes right now in Ethereum mainnet. You will have in general like 6 hopes for like generic nodes from somewhere to you. And in worst case, it will be like, not in the worst, but in some bad case, it will be like 9. So if you will increase your peers, you can decrease this the number of hopes. So anyway, increasing peers, it helps to get blocks earlier. But another problem, another side of it, it creates stress on your software because you need make messages for all these peers, replicate messages there, and so on. So it actually consumes CPU. So it can increase your block import time. It decrease your receiving, you will receive your blocks earlier, but it can make your block import longer because of lack of CPU.
I see. So assuming we have the latest version of that node, like i7 Intel CPU, then 150 peers shouldn't be a problem.
I didn't say that. Let's say that like you need to test that.
Yeah,
This
yeah.
is
So
the only way actually. Yeah,
yeah.
I
So
can
guess,
say like particular number. It's super hard.
right. So I guess we can test, setting 150 peers for 3 days, checking our RAVER score, and then changing it, tuning it down to 130, check our RAVER again, and so on and so forth, and find the configuration that gives us the best score.
Yeah, it's like common way. The best way is just check your head events, like timing of your head events. But you need like a separate infrastructure for that, and so on and so on. So it's harder. And yeah, in common way, you can check just RAVER because it also will be influenced by that. Yeah.
Got it. All right, let's see. Does anyone else have questions? right? I think
Yeah,
just on
I
this,
also saw. I also saw like this last one comment about for some
sure.
Yale client. Yeah, like all of the stuff related actually to consensus layer. On execution layer, we don't have much peers. It's usually 50. Why? Because it doesn't influence RAVER at all. It influences only on your mempool and the number of transactions there. So for vanilla blocks, you should make that only for consensus layer. Yeah, not for execution layer.
All right. So how do we get closer to L1 ISPs? Let's say we are home stakers, right? So we
I
have
think it's
only a few to
impossible.
choose from. Impossible.
Yeah, it's hard. You need to choose maybe to layer one. I don't think it's possible, but maybe to layer two, because some layer two ICPs, they also have some B2C business, and you connect to them. And
Right.
do not choose like layer three, let's say, operators who haven't any like direct connection to layer one ICPs.
I
It
see.
could be work like that. Yeah, why not?
And just for everyone here, how do we define layer one ISPs?
Yeah, so it's called like layers, and we have layer one. Layer one, it's usually internet service providers between different countries. They owns like basic infrastructure, fibers, cables between continents, and so on and so on. They are really big, but a few of them. Layer one, it's usually country-based operators who works exactly in the country. Sometimes it's also layer one, of course, operators, and they creating like abundant like clients exactly in some regions or country and something like that. And layer twos, ACPs, it's usually providers in some city or in some region, in some state, something like that. And usually they don't have like a direct connection to layer one. Usually it looks like layer 3 connected to layer 2, layer 2 connected to layer 1, and layer 1 just allows to like to send all traffic across the globe. Yeah, like that.
Thank you. Thank you. Let's see. Let's take one more question before we let Sergey and Nikita go, because we are just at the hour. Actually, we are slightly exceeding it by 5 minutes. So if you guys have any heart-burning questions, this is time to throw it out. We have one very spicy question from the chat. Any clients you would avoid at all costs?
I can't say anyone of that. So I think it will be not very good from my side to say like that. Sorry.
That is true. That is true. I shall not force you then. Maybe just one last question from my side then. Could you share with us your steps to diagnose problems? When you notice a performance drop. As a professional, what do your steps look like?
I think it's very different from like solo stakers, of course, and it shouldn't be like the same process, because like the biggest difference, because we are collecting a lot of metrics and we can dive deep on them and understand what's going on. I think it's not the case for like small solo stakers with some small hardware and so on. But anyway, like the process beyond of going deeper on data exactly, it just check your nodes and check logs, restarts your node, maybe enable debug. Sometimes we enable that and just checking what's going on with attestations, with block production and so on. So just work with your nodes, check logs, check metrics, use standard dashboard from client developers, and that's it. No magic here.
All right, sounds good. Amazing, guys. Thank you so much for your time again. Super amazing presentation. It gives
Sorry,
us a
guys.
clear look
I have
into.
one more question.
Oh, go ahead, Aurel.
Sorry, Sam. Yeah. I don't know if this has been told, but could we get the presentation? Because honestly, the first few slides, actually, for a newbie like myself, were very, very interesting and useful.
I think yes, why not? It's like we can publish it, and maybe guys from Lido help us to make some, I don't know, some article
Okay.
or some, publish on Twitter. I don't know, something like that.
Yeah, I think
Yep,
that'd be great.
And this session is also recorded, so we'll also snip it up into bite-sized pieces to be shared with the community.
Awesome.
Yeah, awesome. All right, with that, thank you so much, guys. Thank you again for sharing your experience with us. It has been a great presentation.
Yep, thank you, guys.